Assalamualaikum warahmatullahi wabarakatuh. So this is the slide presentation for chapter 2 rectifier. So the definition of the rectifier is actually a circuit that converting AC from mains or other AC source to DC power output using either power diode or by controlling the firing angles of the thyristor, or controllable switches. And as can be shown here is the basic block diagram of the rectifiers. The input can be either single phase or three phase input. The output can be fixed output or variable, and the applications is numerous applications uh, consisting encompasses of DC welding, DC motor drive, battery charger, DC power supply, and HVDC. And this is the tree that shows the classification of rectifier. So in this slide, we will, and on this syllabus, we will go to the first class of the rectifier that we call half-wave rectifier. And under this half-wave rectifier, we have controlled and uncontrolled. So where the uncontrolled, we use diodes as our main components, and for the switch, and for the control, we are using what we call the SCR or thyristor. So the single phase half-wave rectifier, so uncontrolled. So this is the simplest polytronic circuits, okay, consisted of the diodes, which is uncontrollable switches, where meaning that we cannot control the timing of on or off of the diode. It depends on the circuit's conditions. So to turn on the diode, the circuit must be in the forward bias. Sorry, the diode must be in forward bias, and to turn off the diode, the circuit must be in a reverse bias. So as you can see here, the voltage source is an AC voltage source, oscillate at around 22 pi here. And for the positive cycle here, the current is flowing in this direction, and for the negative cycle, the current is flowing in this direction. So as you can see that um, there's a condition where the circuit can be forward bias and reverse bias. So the diode will be in the forward bias, where the anode is positive compared to the cathode when in a positive cycle. So this is a positive cycle, so the diode will on. So when it is on, so it is meaning that the diode will be short circuited, and V out, it will actually shows the value of the Vs as can be shown here. So the value is actually similar to the V source value. Okay, when the source, okay, goes to the negative cycle, what we can see that the polarity of the polarity have been changed. So this one will become negative. This one is become negative. This one become positive. So meaning that the anode is right now is negative compared to the cathode. So this means that the diode is in reverse bias. So the diode will actually turn off. When this diode is turned off, so when we measure here, there's no connection between the output and input, so the reading of the voltmeter is 0. So that's why we have a 0 output voltage here. So this condition, this circuit is operated in cyclic manner, so meaning that every positive cycle we can see that we have an output voltage that equals to the magnitude of the V source. And this is the parameters that's associated with the output voltage, where this is the equation. The first equation is the equation for to calculate the average output, and the second equation is to calculate the RMS output. So I would like to show you on how to um, calculate or to derive the equations, okay, for the average output voltage. So to derive this, so V out average is equal to uh, 1. The equation is a general equation is 1 period over 0, and then you need to actually to integrate from 0 to period, and then the function. Here the function is actually a V out. We just write V out. This is omega t. So here the 1 period is 2 pi. So we need to integrate from 0 to 2 pi, and V out is actually okay, sorry. So from 0 to pi, we have the output, which is Vm sine omega t, okay, plus from pi to 2 pi, we don't have voltage. So definitely this one will become 0. So we only concentrate on the first term. So the first term is 1 over 2 pi, okay, and then this one will become Vm cos omega t, okay, 0 to pi. And since Vm is the value that we know, so we can take it out, factor out, so Vm to pi, so this one will become negative cos omega t pi 0. So when we move further, we expand this, we will get this one is actually equal to 1, negative, negative 1. So we have finally derived, which is the V out average is Vm over pi. So go back here, and this output voltage RMS is shown here, Vm over 2, which is you can calculate also as a 0.5 Vm. And this is the example. So I have already shared with you on the solution, okay, how we can solve this. Okay, so that's all for the single half wave with RL load uncontrolled using the diode.